Girls, today we're looking at graphs of not just sin x, cos x and tan x, which is what we've looked at before, but we're looking at graphs of cosec x, cot x and sec x. Now, the first graph I've got here is y equals sin x. Remember how it's like that roller coaster starts here and it repeats every 360 degrees. That's the sine curve. Starts at 0. I've shown some of the negative part of it as well. Oops. So that is my sine curve, and it starts from 0, 1 period, and then we can continue. If I look at the graph of y equals cosec x, and it's not working, one sec. Y equals cosec, it doesn't recognize it. So it won't draw y equals cosec x. How can what's cosec the reciprocal ratio of? So 1 over sine x is cosec x. Have a look at that graph, girls. Ladies, I need you to look at the screen. So wouldn't you say that it sort of bounces off the maximums of the other curve? So the cosec x graph, look at it, is in blue. Look at it. And the way that you can think of it as is, there's my sine curve, but it bounces off, but there seem to be asymptotes, okay, for that cosec x curve. All right, so cosec, its third letter is S, so it's the reciprocal of the sine graph, and the way you draw it, we will be doing a table of values in a minute, is that it bounces off the sine graph. So cosec goes with sine, it bounces off. But we seem to have asymptotes here. So if I draw the line x is 180, for example, and I'll do it in another color. And if I change it to dotted, and maybe not so thick, but it's an asymptote. Can you see that? And if I do x is 180 as well, I just don't really want it that thick. Not 180. If I do x is 360 as well, but I do it also in green and with some dots. So girls, what I've got, I'm going to get rid of the sine curve now as well. That's the cosec curve. So it bounces off the red sine curve. And there appear to be asymptotes. Look how, when I look down here, the blue graph is approaching that green line but never touches it. Okay, so that's the cosec curve. Bounces off the sine curve. Make some notes on that now. So we're looking at the graphs of reciprocal functions, exercise 5e. We know that, for example, the graph of y equals sine x looks like this. That's not a reciprocal function. That's the graph of y equals sine x, right? But the graph of the reciprocal of sine is what? Third letter S. Which one's got third letter S? The reciprocal of sine is cosec. So I want to draw the graph of y equals cosec x. So y equals cosec x. I want to draw that graph. I know that y equals, that is 1 on sine x. Now, I showed you on Desmos how we draw it. What I'm going to do, we're going to do a bit of a table of values as well. So I've got when x is, I'm just going to do some values, 0, 90, 180, 270, 360. I'm going to do the values for y equals sine x. And then I'm going to look at a table of values for y equals cosec x. Now we know that cosec is 1 on sine x. Okay, and then we're going to see why we had that graph that was bouncing off the other graph before. Okay, so I've drawn the graph of y equals sine x in pink. So everything with sine x is going to be pink. I'll do cosec x in blue. So you tell me, that's the graph of sine x. We know it goes from 0, it has a period of 360 degrees, and that's 180, and we've got 90, and we've got 270. So let's fill in our values, table of values. So I want to do y equals sine x. So the sine when x is 0, what's the sine of 0 according to my graph? The sine of 90. Remember the amplitude's 1. The sine of 180. The sine of 270. And the sine of 360 is 0. Now I know that 1 cosec x is 1 over sine x, isn't it? Isn't cosec 1 over sine x? So it's 1 over 0. Now get your calculator out. Are you allowed to divide by 0? That's undefined. Now, so it's 1 over whatever we've got there. What's 1 over 1? So when cosec of 0 is undefined, cosec of 90 is 1 divided by whatever sine 90 is. So it's 1 divided by 1, which is 1. Cosec of 180, it's 1 over sine of 180. So it's 1 over 0, which is undefined. Okay. Cosec of 270 is 1 over whatever sine 270 is, 1 over negative 1, which is, anyone? So there are our answers. And the last one, the cosec of 360 is 1 divided by sine 360, so it's 1 divided by 0, which is undefined. So there's our graph of sine x. We're going to draw our graph of cosec x. Whoopsie. Now, sorry, my axis isn't very good. Got y, we've got x. Now, we've seen it in Desmos. We saw it in Desmos, but what do you remember about the cosec x curve? It bounces off. The sine curve, it bounces off. So what I'm going to do, in pink, I'm going to do the sine one. Okay. Just dotted. I'll just do, that's my sine curve in pink. Okay, have you got that first one? So that's my sine curve. But where am I? Now look at the table of values that I just did. So here's my sine curve. I've got 0, that's 90, 180, 270, 360, and so on if I want to continue. 360, I think that's 450, 540, and so on, right? 720, whatever. That's my sine curve. Sine curve, it has a period of 360. Now, the cosec curve, I'm going to have to put in what I've got so far. I know that cosec of 0 is undefined. I know that cosec of 90 is 1. I know that cosec of 180 is undefined. So whenever I've got undefined, I have to draw in asymptotes. I know that cosec of 360 is undefined, asymptote. So I've got undefined there, I've got undefined at 180, I've got undefined at 360. I know that cosec of 90 is 1. What's the cosec of 270? Negative 1. Look, I could do other values as well, but it's just going to be too time consuming. For you just to do the quick sketch, have an idea of what sine looks like. Remember the other one? Bounces off. So here's my cosec curve. Now I'll go back and show you Desmos what we had. Look, to know that these are the values, yes, we can try cos of 350. We can try cosec 190, cosec 350, cosec 10, cosec 170. You'll see that it does approach those values if you do choose those values. If you want, actually, so this is the graph of y equals cosec x, which is, at the moment, using our calculator, all you know is the value for 0 is undefined, asymptote. 180 is undefined, 360 is undefined. Cosec of 90 is 1. Cosec of 270 is negative 1. You don't know the other values until we probably get our calculators out and try a couple. So girls, can you work out, for example, just going to do a few values here. What's the cosec of 10? Now, you can't do it directly on your calculator. How do you do cosec 10 on your calculator? 1 over sine 10, and give me an answer, approximate. Just to 1 decimal place will do. What's 1 divided by sine of 10? And then can you also do cosec, say, 80 for me? And let's do cosec of, not 80, cosec, sorry, 170. Can you do cosec of 190? I just want to do before and after the asymptotes. And cosec of 350. I want all these values. So, you know, they're all actually going to have the same magnitude, but they're going to be different signs. So cosec of 10, can I have a value, please? 1 divided by sine 10. So I'm just wanting to know this value, this one, just to make sure I'm drawing the graph correctly. Cosec of 10 is 5.8. You know how this is the 0.1 here? I've got to put those in, and that's the point -1. Cosec of 10, about 5.8. It's up there somewhere. Cosec of 170 is up there. If I do even closer, girls, if I do cosec of 1 degree, I'm going to get like 100 or something really big. So the graph approaches these asymptotes but never touches it. If I do cosec of 190, what do you think I'm going to get? Because I'm 10 degrees from there. A positive or a negative answer? Can I have someone do that? What do you get? Negative what? 5.8. And do cosec of 350 and you'll also get negative 5.8. You know why they're all 5.8? Because I've gone 10 degrees from each asymptote. I've come in 10 degrees from each asymptote. That's why I'm getting the same answer. All right? So, girls, if I want to keep drawing, I can keep drawing. So, in blue is the cosec curve. In pink is the sine curve. The cosec just bounces off. So, I'm going to put another asymptote here and another one here. And I bounce it off this one, yeah? And I bounce it off that one. So that's cosec. So what could you say? The cosec curve bounces off the, so you've got your asymptotes, it bounces off the sine curve. And isn't it great? Because cosec's third letter is S. So y equals cosec x, it sort of bounces off y equals sine x. But it also, but y equals cosec x has asymptotes. Where are the asymptotes? Where the sine x curve is 0, because you're doing 1 divided by 0. Where sine x equals 0. So it has asymptotes at 0, 180, 360, etc. Okay? So y equals cosec x bounces off y equals sine x. It has asymptotes where sine x is 0, because you've got to do 1 divided by sine x. So every time you're doing 1 divided by 0, that's an asymptote. All right, so girls, don't forget to put, if you were to draw it, that they bounce off at 1, because 1 divided by 1, 1 divided by -1. 1 divided by 1 is 1, 1 divided by -1 is -1. So that's your graph of y equals cosec x. Dotted one is sine x, the pink one, and the cosec one bounces off. And wherever sine x is 0, because you're doing 1 divided by 0, that's where you put your asymptotes for cosec, because cosec is 1 divided by sine. Okay, next graph. Cosec, it's like the roller coaster, starts at the top. And one period is 360 degrees. The cosec x curve bounces, sorry, not the cosec, the sec curve, which is 1 on cos, sec, third letter C, bounces off the cos curve because you're doing 1 divided by whatever result you've got there. Look, 1 divided by 1 is 1. Here, cos is 0. 1 divided by 0 is undefined, asymptote. Here, cos of 180 is -1. 1 divided by -1 is -1. Here, cos 270 is 0. 1 divided by 0 is undefined, asymptote. 360, cos of 360 is 1. 1 divided by cos 360 is 1 divided by 1 is 1. If I did the values of, let's say, 80 degrees, 100, etc., on either sides of the asymptotes, you find that the curve is approaching those asymptotes as well. All right, so let's take some notes on that. All good? The graph of y equals sec x, we just did y equals cosec x. So that's the graph of y equals cos x. You know, it starts at 1 down to -1, period of 360, and we've got 90 and 270. So if we want to draw the graph of y equals sec x, it's the reciprocal of the cos x curve. Because cos of 0 is 1, just looking at the cos curve. Cos of 90 is 0. Cos of 180 is, what is it? Come on. Cos of 180. I've drawn the curve. Cos of 270 is 0. And cos of 360 is 1. So sec, y equals sec x, is 1 on cos x. So just looking at those. So we do 1 divided by 1, which is 1. 1 divided by 0, undefined. 1 divided by -1 is -1. 1 divided by 0, undefined. And 1 divided by 1, which is 1. And then we can sketch it. So I'll do the cos curve dotted. Might do more than 1, we'll see. So we go to 360. I'm doing 2 periods up to 270. Wherever you've got 0 in the cos curve, because you've got to do 1 divided by that, you're going to have your asymptotes. Wherever the cos curve is 0, 1 divided by 0 will give you where the asymptotes are. And then what do we just do? We bounce off the others. So you just bounce off the cos curve. And you approach the asymptotes. You know, asymptote, graph approaches the asymptote but never touches it. So that's your graph of y equals sec x, which happens to be 1 on cos x. Okay? Now, yes, we can try sec 80 and all that sort of stuff, but we did it in the other one. We don't need to do it again. 270, 360, etc. I think halfway is 540. Yeah. I'll just zoom that in now. Y equals tan x. When you do tan 0 on your calculator, you get 0. When you do tan 90, you get undefined. All right? So, girls, when I do, where do you think the asymptotes are going to be for my cot curve? Remember, wherever this curve is 0, that's where I'm going to have my asymptote for the next one. So, what's 1 divided by 0? Undefined. But what if 1 divided by 0 is undefined? 1 divided by undefined is 0. So what's going to happen, girls? It goes the other way. Look at the blue one. That's cot. So girls, having a look. Where the tan red curve, so I'll just get rid of the asymptotes for a minute. Now, where the tan curve was 0, that's the red curve. The cot curve is undefined. Where the tan curve was undefined, so where red curve is undefined, the cot curve is 0. So you know how 1 divided by 0 is undefined? 1 divided by undefined is 0. Okay? So we define cot 90 has a value of 0. Cot 270 has a value of 0. But tan of 270 is undefined. Tan of 90 is undefined. All right, so have a look at it. It goes the other way. So if you just know 1 divided by 0 is undefined, 1 divided by undefined is 0, where do you think they're meeting but? Oh, there, I've just shown you. You know how tan 45 is 1? 1 over 1 is 1. So cot 45 is also 1. That's where they cut. Okay, so it just goes the other way. And wherever the other one was undefined, it's now 0. Where the other one was 0, it's now undefined. So the curves go the other way. Okay? Because we're drawing y equals cot x, but we'll just revise what y equals tan x looks like first. Remember that tan of 0 is 0. Tan of 90 is undefined. Tan of 180 is 0. Tan of 270 is undefined, etc. And tan of 360 is 0. What's the period of the tan curve? Anyone? 180, yeah. It repeats every 180. Now, we do know that tan of 45 is 1. All right? So this one, 0. And it just keeps going the same way. You know, they're all going this way like that. That one would go like that. So that's tan. I might just put another little section in. And if I was to continue that there, that would go like that too. Do you know what value this might be over here? Negative what? Yeah, negative 90. And this over here would be another 180 from there, which is, I think, 450. Or another 90 from there. So that's your tan curve. And I've drawn beyond 360, okay? So our cot curve, that's y equals tan x. I'm not going to draw it on the same one this time. It just gets too messy. I'll draw it on the other one. So girls, wherever you had 0, you now have undefined. And wherever you have undefined, you now have 0. So where are the zeros going to be? Zoom out. All right. Where we had 0, we're now going to have undefined. And where we have undefined, we're now going to have 0. So what's cot? So this is y equals cot x in blue. That's tan x in pink. Let's go. What's the cot of 90? Cot of 180, undefined. And it repeats every 360. So tan of 270 is undefined, so it'll be 0. And it goes the other way. Now to check, you can just check. Just do cot of 10. Are you going to get a big value or a small value? How would you do cot of 10? You do 1 divided by tan, and you should get something pretty big. Okay, so your cot curve goes the other way to your tan curve. Okay? That's cot x. Now we can do that little table of values if we want. So x, 0. I might put 45 in. 90. 135. 180. I'll just do 270 and 360. I've put some 45s in for this one. So for the tan x curve, what are our values? Tan of 0, 0. Tan of 45 is 1. That's undefined. Tan of 135 is negative 1. That's 0. Tan of 270, undefined, and 0. I'm just putting your tan x, and then we'll do the cot x underneath it. I threw some 45s in there as well, because tan of 45, and so same as cot of 45, they're both 1. Okay, what's this first one? What's the cot of 0? It's 1 divided by 0, undefined. The cot of 45, it's 1 over 1, which is 1. The cot of 90, it's 1 over undefined, which is 0. Cot of 135, 1 over negative 1, which is negative 1. And so on. Okay?